Chapter 17, the Thyristor, a silicon controller rectifier. The thyristors are used for very high-speed switching application and very high current ratings. Most common are SCRs. The device has a positive feedback. It acts as a latch, so it doesn't let the data to be lost even though power is off. So when it's turned on, it tends to stay on. When it's turned off, it stays to turn off. The SCR consists of 4-layer P and PN layer. There is a gate terminal at the P and anode and a cathode at P and N. It is either diffused or constructed with the alloyed. The planar construction is for very low power SCRs. Now there is a P-N type and N-type semiconductor material doped to make an P and PN layers. Now there is a gate in between an anode and a cathode on the outside. Schematically it is shown as figure. At the switch that can turn on and off or small or large amount of power, it performs this function with no moving parts. That's why there is no wear and tear, no points replacing. It can produce a tremendous power again in the SCR. In some units, a very large triggered current is able to switch. The SCR can often replace much slower and larger mechanical switches. Though this is a schematic test circuit, we give the sine wave of 20 volts, amplitude of 1 kilohertz to the V control, and that's the SCR we give to the gate. We gave the various R value to the R. We have like 1K, 5K, 10K. Now this is the power control waveform at 1K, 2K and 10K. Now this is the switching characteristic we understand. The green one is the V anode voltage at the anode, this one, and the yellow one is the yellow, red, and purple one is the IRL at the different value of resistance. So at different value of resistance we get a different waveform. So that's all the points we get from the graph. Now this is for the input of a square wave. That's the switching at the various value of RCR with the square input value. Chapter number 17, the Thyristor. Make a blank project. That's SCR schematic. Load all the values. We're gonna have SCR net of 2 and 1595. That's an SCR with anode, cathode and a gate. Connect the gate for at R bias, cathode to the grounding. Let's supply V source. Connect the resistance RF. Give the ground to here, to every source, or here too. Connect the components. That's V anode. Set the parameter of RL 10K. We have first selected 4K, sorry. V on and off. V amplitude of 20 volt. Frequency of 1 kilohertz. R control, which controls the gate for the transistor, thyristor. This is the parameters. Label it as RVL, the control resistance of 1K. RVL. 1K, 5K, 10K. V anode at 3, V anode at 2. That's the V anode at 1. So it's 1K, 5K, 10K at 3. Now add the y-axis as a R control, current flowing to the load resistance. So we will find the holding current for that. This is the RL at 3. Find the value. Keep on tracking. That's nearly almost 1 milliampere. Change the value. Now we're gonna change this. It's a square wave. So give the input a square wave and simply add capacitance. Now we will use a capacitance to vary the turn on time and a delay time, turn on delay time. So this is capacitance and the input will be the square wave. So we can give the square wave input towards schematic. Give 20 volt DC supply. Point 0.5 microvolt. Zero volt. That's the V trace. That's for the voltage at anode at 3, voltage at anode at 2, and voltage at anode at 1. For the square wave input, that's output for different value of VRC, different value of gate current.